Paniagua, and this is our group's NAE Grand Challenge project. The, the challenge we decided to tackle was providing access to clean water. Some issues that we found facing this challenge and that we decided to focus on were a country's wealth and their GDP, and how much it costs to clean or purify water. The data set we found gives us every country in the world along with their GDP, and the three solutions we decided to go with are LifeStraw, ion exchange, and desalination. LifeStraw is a company that produces a straw that purifies the water as it goes through. We found that it cost about $20 to buy one LifeStraw. However, we did not take into account the taxes or how much it costs to import it or produce it. All we took into account was how much it costs to buy one. Ion exchange gives us about 1,000 gallons of water per dollar. However, we did not take into account the cost of the equipment needed. Lastly, desalination purifies ocean water. However, we did not take into account how much it costs to maintain one of these desalination plants. Now let's look at the code. First, we imported the Excel data into variables based off their individual columns on Excel. And we have every different variable listed here. However, the two most important variables that we focused on were the GDP and the country name, because that was what our code focused on. Now we start our code by asking for a user input. The user inputs the name of a country, and we save it under the variable pick. Now we go from there to find that country in our Excel sheet, and save the location variables R and C. From there, we could find the GDP of that country by going into the variable GDP billions, PPP, and placing in the row that we found where the country was. Next, we output this GDP. Next, we ask for a user input of what percent of the country's GDP would they like to invest in water. We also have a warning here that if the percentage is 0 or below, there will output a warning that it cannot be negative. And then it will ask again what percentage of the country's GDP would they like to invest in water. We then calculate how much of the GDP is used by dividing the percentage by 100 and multiplying it by the GDP we found earlier. This new GDP is how much we're going to use, and we output this in our next fprintf statement. Next, through a menu, we ask the user what method they would like to purify water based on the three I gave earlier: LifeStraws, ion exchange, or desalination. And next, we're going to calculate how much water is clean based off of their choice. If the menu is equal to 1, which is LifeStraw, we multiply the GDP by 1,000,000 because of the way it's saved in the Excel file, and divided by 20, which is the cost to buy one LifeStraw. We save this amount under the variable amount and make an fprintf statement to show how many LifeStraws they will be able to buy. If the user picked ion exchange, then the method will be equal to 2, leading us to our else if statement. From here, all we do is multiply the GDP by 10,000 to give us how much water it can produce, because ion exchange produces $1, produces 10,000 gallons per dollar. And again, we just fprintf statement this to show how much gallons of water can be produced. Lastly, if they pick desalination, we then ask how large they would like the desalination plant to be in units of acre-foot. After they input this, we see how much it costs by multiplying it by 2,000, which is the cost per acre-foot, and we make sure that this cost isn't greater than the GDP used to make it, because if it is, then the GDP will not be able to fund this size of a plant, and we ask for a new size plant. From here, we multiply by 2,000 again to get the overall cost in acres of the plant, just to make sure again that it doesn't exceed the GDP. And then if it doesn't, we go on to the next step, which is multiplying the size by 326,000 to find out how much gallons of water it produces, because a desalination plant produces 326,000 gallons of water per acre foot. And then again, we printf statement that amount. Lastly, we ask the user if they would like to survey another country through menu, yes or no. If yes, this entire process starts over again. If no, the code ends right there. Now let's give a few test cases. So I'm going to run it and go to our command window. First, ask for a country. We will enter Iran. It shows that the GDP of the country is about 990.22 billion. It asks what percentage of the GDP would we like to invest in water. We'll put a very small amount, 0.1%. And as you can see, by moving the menu, it tells us we will invest $0.99 billion, which is still a good amount of money. For this test case, we will go with the life straw. So we click life straw. And it says we'll be able to make 49,511 life straws. Let's survey another country. This time we'll go with Colombia. The GDP of the country is about 471.96 billion. We will invest 2% of this GDP into purifying water. And this time we will go with ion exchange, but before that, it says we will invest $9.44 billion. Now let's click ion exchange. And it tells us we will be able to produce 94,393 gallons of water. Let's survey another country this time and make it South Africa. The country's GDP is about 555.13 billion. We will invest 3% of this country's GDP in water. Now, if you notice, all these amounts that we are investing are very small, because in reality, most of these countries will be investing small amounts of water into their GDP, small amounts of their GDP into water. It says this 3% is equal to $16.65 billion, and let's go with a desalination plant. And we'll make it about, let's say, 100 acre foot. And as you can see, we can produce about 32,600,000 gallons of water. And let's do one more test case just to see a warning. Lastly, we'll go with India. The country GDP is about 4,457.78 billion. And we'll invest 2.5% of the GDP into water. Let's go with desalination one more time. And let's enter a large acre foot. As you can see, this is very large and will most likely exceed the amount of the GDP invested. There you go. Warning, GDP cannot fund this large of a plant. And it will ask again, how large would you like the desalination plant to be? And let's make it very small this time. Very small, almost unrealistically small. 3 acre foot. And as you can see, if this plant were to exist, it could produce 978,000 gallons of water. And let's stop the code by pressing no. And that is our NAE Grand Challenge project code. Thank you.